we are welcome back, and then we continue today with the quick overview of machine learning modeling, and the modeling process, which is iterative. However, today specifically, we're going to look into what I call the three important things about machine learning modeling. There are three things that we have to focus on. If we get them right, so hopefully, most likely, we can get our modeling correctly and hopefully achieve better outcome of our study. And this is part of our series which we call Important Clarification Series, with the theme Always Let the Data Speak. So we move on. What are these three things? We say the three most important things in machine learning, they are the feature. So which is the representation of raw data. So when you talk of data, what is data? Data is not about combination of several features in one data. So what is feature? How do you get feature from? We come back to this. After that, we have the model, which is often described as the mathematical summary of features. That is, for me, I call it the optimal structure that is detected by the algorithm, by the machine learning algorithm in a data set, in order to achieve the assigned task. There are some hidden patterns, hidden information inside the data set. But as human beings, we cannot detect this. But machine learning algorithms have been developed in such a way that they are able to go into the data set and then come up with something that can summarize the relationship between the input and the output. And then they come up with this summary, which we refer to as model. This model, then we can then take it and use it for future estimation or prediction or classification, depending on the problem we are trying to solve. So after that, the next thing, which is the third thing, very important, is making something that works. You may have the model, you may have the feature, so you need to choose the right model. The right model is very important. And even choosing the right feature, given the data and the task at hand. It means this is where experience matters. You need an experienced data or machine learning modeling expert to be able to do the right thing. Especially if you are just starting, you need a mentor to be able to guide you through when you are facing challenges, to know you have done the right thing. So these three things are very important. Even if you have the best of the best machine learning modeling expert here, without the appropriate feature, he cannot do anything. The model has to be generated before he can get something reasonable. So the three of them, they are very, very important. And that's why we call it the three very important things about machine learning. So we're going to look further into them one after the other. So especially for this, if we look at some of our previous videos where we compare gardening with a machine learning procedure. So you need an experienced farmer or a gardener to be able to apply the right fertilizer, to plant the right seed, to give the right spacing. All this knowledge will have to be provided by the professional gardener who has this knowledge. The same thing goes on here. To make sure that you are developing something that will work, you need the experience, which is actually learned over time. And that is why we always encourage learners and our members to always try to implement the little you've learned. Don't wait until you learn everything. Machine learning, you get better with practices. To keep practicing, get data sets, try to model it, you run into some challenges, you come back and ask questions, and then the learning process continues until you become really very experienced. So experience matter, the system matter, and also the model you are building is also very important. Now, let's look at the feature. What is feature we're talking about? The feature could be about individual. It could be about an individual. It could be about things, about houses, cars. I want to build a machine learning model that can estimate the second-hand value of a car. You can build that. It could be about neighborhood. We want to predict which neighborhood we experience flood. We don't wait for the floods to happen. We want to be proactive in our system. So we want to proactively predict that a particular neighborhood will suffer from flood, so that we can raise an alert to the government and the concerned people to take action before the flood actually takes place. It could be about group, it could be about companies, and just mention anything you can imagine. So future is not something that is specific to an individual. It could be an individual. I want to be able to proactively diagnose if somebody is suffering from a particular disease. In that case, I need feature about that person, the weight of the person. What's the weight? What's the height? What's the history of his parent? Does any of the parents suffer from the same disease, like father or mother? Because sometimes it could be hereditary. So these are features about individual. It could be about neighborhood. What are questions that I want to ask? We say usually the initial peak of feature is always an expression of prior knowledge. That's what do we know before about this thing we want to model. It could be an image. If it's an image, then we'll be talking about the pixels, the contour, the texture, and also others. It could be about signal. We look at the signal samples, the spectrograms, and other characteristics that are related to signal. It could be about time series. We look at the tick, the twine, the reversals, and also further characteristics of the pen. So when you're talking of feature, you are talking of the characteristics that can define an individual. What can make someone to be different from the other individual? What can make a neighborhood to be different from another neighborhood that can determine if a neighborhood will suffer from flood or not? We have to look at the topography of the area. Is it close? Is it near to a dam? You see, usually if you have a dam close at the top of a particular neighborhood, this kind of neighborhood is the potential is continuously under a threat of possible dam collapse. So we don't wait for the dam to collapse. We can make predictions based on other characteristics or features of this neighborhood. It could also be biological data set. If you're talking about biological data set, we may have to be talking about DNA, the marker sequencing, the genes. Usually I like to on something very simple. What of blood count? Blood count. Very simple way of actually diagnosing chronic diseases. You see, because lots of people talk of DNA, not everybody have access to DNA, marker sequencing, genes, expressions. These are things that people need sophisticated machines. In most clinics and hospitals, they don't have the capability, they don't have the capacity. The equipment are not available to measure this. We want to build a model that is applicable to majority of the community, not only to super medical centers. So a simple blood count, anybody can do it in any simple clinic. How many blood count, the HB, the hemoglobin count, and very simple things to do. And sometimes, actually, we're taking it another level. We say, okay, why don't we build medical model that we use? Simple questionnaire. Just ask people some questions. How do you feel? Because even sometimes, even though people have access to medical facility, they are so busy that they don't have time to do checkups. And by the time they detect the disease, it's only very late. So why don't you have a simple questionnaire so that while you are relaxing, you can be answering these few questions on your set. And then based on this, the machine learning model built can then predict if you need to see medical doctor as soon as possible. And sometimes people who do have access to medical facility or no financial wherewithal to do medical checkup, then simple question can actually help them to determine if they are actually having underlying ailment unknowingly. Because often by the time chronic diseases are noted because of a complaint, it is usually at the late stage before the complaint comes out. Because human body are built in such a way that organs can withstand several disease ailments for several years without any symptom. But by the time the symptom is out, it is too late. So we don't want to wait for this. Then we can come up with modeling. So what are the features we want to use? Biological feature, we can be thinking of blood count, even simple questionnaires for people. It could also be text data. Text data. which include the word, that grammatical classes, relations, so many things we process, we speak every day in, day out, type it on the net. We have to bring out what are the characteristics in those texts that we can make use of. This is not new. This has been in vogue for long in what we call the NLP, natural language processing. However, the integration of machine learning to natural language processing finally led to what we now call the ChatGPT, that is changing the way we write, we do things in the AI community and the world at large. Now, so moving further, usually we need these features because there's a problem, a general problem in learning. When you train an algorithm, the general problem is where to focus attention. Where do we focus our attention? Which of the features are important? Which are not important? You see, even experts will not agree on which feature is more important. You talk to different experts. This one is saying feature 1, 2, 3 is the best. Another one says feature 4, 5, 6 is the best. So even experts sometimes don't agree, not to talk of machines. So, and there's this garbage in, garbage out. If you bring in a wrong feature, you are most likely going to get a wrong result, weak outcomes, poor performance of your model. So we want to be sure that we are bringing in what is necessary, but sometimes we don't even know what is necessary. So sometimes less is better. We have explained the cost of dimensionality in our previous videos. Cost of dimensionality is a problem with machine learning training process, that the more the number of features you have, the more the number of samples you need to provide, and the more is exponentially. You see, the number of samples needed when you have one feature X1. Let's say we need like 2 samples to be able to build something reasonable. When you have X2, you have 2 features. You expected that you're going to have, you need like a 10 plus 10 the samples. No, you need 10 raised to power 2 now. That is 100. When your number of features becomes 3, then you need 10 raised to power 3, which is 1,000. This is called exponential growth. Anything that is exponential, that's growing exponentially, is not solvable. It means if you have only 3 samples, 3 features, you are expected to have 1,000 samples. But sometimes you don't have it. We have a problem solving that we have the client sent us 17 features with only 300 samples. How do you do that? 17 features, ideally we are supposed to have 10 raised to the power 7 samples. But now we have only 300 because the data is not there. What do we do? So this is the problem. Where do we focus on? Among these 70 features, what are the important features that we have to focus on? Let them bring it. Let the expert allow us to have access to all the data sets, all the features. Then we might have to, based on the experience, which I say is very important, we may have to investigate feature selection. Which of these features are better and that will give us better outcome? That's why we say sometimes less is better. But it's good at the beginning to have all the possible features you can gather. Gather all of them. Machine learning has a provision for feature selection. So through appropriate feature selection deployment, we can be able to come up with the appropriate method, that is the appropriate optimal number of features that will work for us. We said the universal problem of intelligence on learning agents is where to focus attention. So what aspect of the problem at hand are important or necessary to solve? For example, you want to identify somebody, you want to recognize someone at the crime scene. We use fingerprint. People don't have fingerprint. I used to hear this until I met somebody personally that doesn't have a fingerprint. If you press his hand, nothing is coming out. The hand is smooth totally. There are people like this. They are very rare. What happened, I was opportune to meet one of them, a professor colleague, some time ago. He had no fingerprint. So it means if you deploy fingerprint, that kind of person cannot be detected. It won't work for him. Then you have to look at features from multiple angles. Okay, what if you can use fingerprinting? What facial expression? Recently, now that's a kind of blood. That's a blood. There's a kind of blood stream under the close to the arm, the close to the palm. That just a little scan can determine the person. And they say no two people share this kind of trait. So every day people are coming up with new features that we can use to differentiate between one individual and another. And it could be about neighborhood. So we have to look at them, what aspect of it. Sometimes we might have to go to use heterogeneous features. Picture from the leg, picture from the hand, picture from the face. So many pictures, sometimes we mix them together so that we can be able to recognize in a better way without error. Then we need to be able to discriminate between the relevant and irrelevant parts of experience. Not all experiences are good. Some will confuse the model more. So we have to be able to differentiate between them. Then moving forward, still under the feature, because feature will lead to data set. We have what we call the dream versus the reality. The dream and the reality. This is our dream. We always want data set that's so easy. It's already in a CSV file. So we can easily make it into data, break it down to training and testing and build our model. The task is done. Celebrate. You see? But the reality is there. Sometimes you have data sets that are in different formats. Some they are inside Oracle SQL, some is a log file, some in Word document text, some they are audio. You are able only to have audio voice. Sometimes they are images, sometimes even moving images, which we call videos. Because video is just combination of several images, because they're moving images, videos. So when you have this, then you have to determine which kind of features am I going to bring out of this? Is this one enough? Do I go for this? Do I go for the one inside the database? The audio I'm going to use, or video, or the images? Sometimes you may have to start investigating. Start with the one that is easier for you. Maybe with the database, you can easily create a VSV file. Use that one. If it solves the problem for you, that's great. But sometimes it doesn't solve it. You may have to integrate this and this one. Maybe you use audio only. Then you may have problem with people who cannot produce audio. So you have to decide, depending on the problem you are solving, which kind of feature we allow to come in. So sometimes we may have to do multi-feature type, heterogeneous, data type from different sources, and then we can mix them together. And this is where you can test the power of ensemble modeling. Ensemble modeling gives you that power. You can train a model using this data, train another model using this data, another model used. Then you can combine them in an ensemble to let them jointly take decisions. Hopefully, you can get better outcome than what an individual would say. The big question that reality pushes at us. This is what everybody wants to have. If you have this, you are very lucky. You go ahead, you can model your data. But sometimes your client brings something like this for you. Yeah, you have to deploy your experience to see how do we go about it. Once you are able to select the appropriate feature, then you have machine learning ready data set. Then your modeling can start. You can start building your model, and then the task is done. This is under dream versus reality. We always hope to have the dream data is data set that is easily combined, is easily adaptable to be used directly in model building. However, in reality, sometimes we might have to face this very complicated scenario that the data is not in the format we are expecting, but you can easily deal with it. You can take appropriate decisions, consult experts to guide you on how you can go about it, because don't just run away from them. Sometimes it may be the one you don't like, the format you don't like, that may be where the best result will come out. So that's why sometimes, of course, it's always good to start with something simple. If you have this, then go the one that you can easily prepare for exercise so that you can start your modeling. If you get worse, you are not getting good results, then you can start exploring this complicated one. it's always good to take it simple. Don't start from complicated idea. Now, having seen the features and now they interact to build the model, because once you get the feature, you can build the model. The next thing is, which kind of model should I select? Which model should I go for? Which algorithm? Support vector machine, neural network, Bayesian Bayesian network, logistic regression. There are so many of them, and new ones are coming up. Or is it the ensemble one I want to use? Again, this is taking us again to the experience I mentioned. The third thing, it depends on your experience. So what have you used in the past? That's important to know that which one is the best, the big question. No one can really tell. No one. If someone tells you that vector machine is the best machine learning algorithm, that person probably doesn't understand machine learning properly. If you understand machine learning properly, there's no algorithm that is really best. It depends on the problem you are solving. So that's why we always say that let the data speak. The data will determine which algorithm will work for you. If we've used support vector machine, very powerful, especially if your data set is very few, because of cost of dimensionality. It has a lot of very strong theoretical background. However, we have used it on some data set that it doesn't work. And nearest neighbor, which is considered lazy classifier by some people, perform excellently well where vector machine failed. So there's no machine learning algorithm that is best in our situation. You have to try it out and see how it works. So based on this, when you model with machine learning, you have to take note of this. There's no free lunch. So machine learning algorithms are tools, not dogmas. They are tools, not dogmas. You see, tools can fail. They can work in one situation, another situation, they may not work. Dogmas are things that are fixed. They don't change. No matter what comes, you meet them as they are. So machine learning is not a dogma. It is what? This is a tool. So you use it, it works for you sometimes, it may not work, you have to try other ones. So we say no algorithm is inherently better than any other. You need to make assumptions to generalize. So this is where your experience come in. You have to have the experience to say, okay, what should I do? It's not working. Try simple algorithm. We always advise. Start from simple algorithm first. The first thing you do is to start from simple algorithm. Don't use complicated algorithm, use simple one. Like nearest neighbor, KNN, decision tree, naive Bayes. These are very simple algorithms. Let's see if it works for you. And sometimes it works. It is when the simple ones are failing, then you start going to more complicated or sophisticated ones, like support vector machine, neural network, planning, and also others. See, unfortunately, a lot of people make mistake in this. Once the data set, because deep learning is in vogue, they quickly go for deep learning. There was a very popular problem, which was on a security problem in oil and gas. The authors went for deep learning to solve a problem with simple numbers, simple numerical values. And they were struggling with 85% accuracy. That was the maximum they could achieve. With simple nearest neighbor, even though we were not done with the hyperparameter optimization, we already achieved 95%. You see, they ignore it, they went for the complicated one, but found out that they were actually wrong. What we are saying is try simple algorithm first on your problem. Let the data speak. Let the data tell you that no, this is not working for me. Let the data speak. So this is the idea we have to always note, that there's no machine learning algorithm that is always better. Also, better to have smart features and simple algorithm, simple features and smart algorithm. Pay attention to this. If we're talking about features, modeling, and the experience that you need, produce what is better as the outcome you're expecting. So it is better to have a smart feature. Smart feature, they are features that are very relevant to the problem you are modeling. You see, you can use feature selection to select the smart feature. And a simple algorithm will work for you. Having a smart feature, a simple algorithm is better than having a simple feature that does not represent the problem you are solving very well, and a smart algorithm. Unfortunately, people go but always they settle for this. They look for very sophisticated algorithm and then feature that may not be relevant, and then they miss the point. Those underlying characteristics in this area you are modeling will be missed. So there's no, that's why we just mentioned that there's no algorithm that is better in all situations. But if you have the correct feature, the appropriate feature, then you can always use even simple algorithm like the example I gave here. You can use it to get your better result, which make your life easier rather than deploying complicated. Some people just decide to go for ensemble directly without even trying simple algorithm. No, we don't do that. You have to try from simple algorithm and gradually you graduate to what the complicated one if in case the simple one does not really work. So, and then last but not the least, use increasingly powerful algorithm with more training data. We call it the bias variance trade-off. We can listen to our videos on bias variance trade-off in our YouTube channel already. You see, the more the number of training sets, the better. You can start increasing. Okay, after we notice that okay, the data is getting more, we have more data set, simple algorithm is not able to do this, then we can go up. See, for example, you have very few samples like 16. You have simple distinct number of samples. Very small. Very, very small. Try with those simple KNN decision tree and see if you can get something. Support vector machine, we've had several sections with support vector machine. It has some unique characteristics that make it to work on few data sets. When your data set is very, very simple, you can try support vector machine in addition to the simple algorithms that you are trying. But as the data is increasing in number, then you can start trying neural network. Neural network should not be tried if your data is very few. No, neural network needs substantial amount of data set to be able to work properly. All things being equal. So all these procedures we just mentioned, the good note is the procedure is always iterative. You can always go back. So this is where you talk about the feature. This is why we deal with the feature. What are the appropriate features we want to do? We want to use? Do you select the one that is better? Where you are getting the feature from, don't waste your time out what to give you. For example, if you go to medical center, they say, okay, tell us which data do you want? What are the characteristics in the patient you want? Just then, please. And you give us all the available characteristics that is present in your system. Because they will ask you to go and talk to a medical doctor to tell you what they use to diagnose kidney disease, for example. Doctor, we said this, we said this. We are saying, please, can you give all the available information about your patient? Machine learning will be able to determine, using feature selection, which of those features are more important to what we want to model. Because sometimes what our medical doctor were taught in school long time ago, things are changing. The food we are eating is totally changed now. You see, the constituent of our food, due to this genetically modified food, they are changing. So the characteristic that present itself for a particular diabetes patient 50 years ago may not be present today. So let us get as much features as possible, and we can use feature selection principle or feature engineering to engineer the features so that we can be able to select smart features. Don't forget, we are looking for smart features. And we can be able to use even simple algorithm to solve our problem in a unique way. So this is where you select the algorithm to be selected, the performance measure, and your experience will work here. Once you check the performance measure, you can decide, okay, should we go back and change the algorithm, do the hyperparameter optimization, or change this algorithm, or go back all along feature engineering. Try to combine some features to make more superior features, to make more smart features. For example, we have date of birth. Can you break it down into 3 features so that you have day, you have month, and the year separated instead of combining them as one single feature? This is what we do in feature engineering. And sometimes you might have to go back entirely to the data preparation stage, whereby you have to get more features that you didn't get before. Maybe you are only using facial expression for the recognition. Can you bring in the fingers? The size of the fingers have been used in a lot of forensic investigation to determine the identity of someone. See that the size of the fingers will determine your age and host of others. So you might have to go back. You always have this luxury of going back. That flexibility is there. So you don't need to get it right at once. So check, start from simple algorithm, increasing it to complicated one if the need arises. So this is the modeling procedure about 3 things that matters in machine learning. The features, they're very important. The model you want to build, very important. Which of the algorithm will work for you? And of course, you need the experience to be able to build the right model. So I believe this is where we're going to have it for today because of time. Thank you very much for listening and remain blessed.